While you're going through it, I will set up the remaining things, right? Oh, good crowd today, huh? Come. So what you should do, folks, is while I'm plugging in the other things, I'm sharing a link with you. If you could take maybe 15 minutes to familiarize yourself what this topic is, and then we will start doing some hands-on practice on it, right? So I just posted this link on the chat window. So once you log in, please take a look. We'll take about 15 minutes to go through the link, and then we'll get going.
Good morning, RP sir. So I have a doubt from the last session. Sai, am I audible?
Yes, ma'am, you're
Next
audible,
week.
but sir is away from the mic.
Before you forget.
Hello?
Yeah, hello.
Yes, I can.
Ma'am, sir, Bhavna was asking some doubts.
Yeah, Bhavna, go ahead.
Yeah, good morning, RP sir. So I went through the last session when we
Uh-huh.
did this auto glue on, right? You remember
Uh-huh.
we get the leaderboard, right, of the models which can be used.
Yeah.
And before that, it runs and it gives us what is the best model. So the
Yeah.
question I have is the leadership board and the best model which it gives us doesn't match, right?
Because it's a difference between the training and the test data, Bhavna, right? So
Okay.
when it is showing you the leaderboard, that is
Hmm.
on the test data. When it is
Okay.
giving you the best model, that is on the trained data. But the difference won't be that much if you look at the statistics of those models. I mean, they wouldn't be like a day
Okay.
and night different in terms of.
Okay. Okay.
You could do it both on the same data, like the leaderboard and the model performance on train, but it was taking slightly longer. So if you have, good GPU, then you can try to do it
Hmm.
on the same data, and then you'll get exactly the same results.
Okay. Okay. Sure. I think I'll try this because when I went through the last session, I was a little confused with this.
Got it.
Just wanted to
Okay.
clarify.
Yeah.
Thank you.
Cool. Thanks. Ah, yeah. You're taking yeah. Mm-hmm. Free training. Acha, acha. Got it. Mm-hmm. Yeah, absolutely. That's what we usually. Absolutely. I would say so, but not completely. So I'll just maybe pull up one of the things that I actually read recently. I'll talk about that, uh, which will make more sense. I mean, once I go through that particular article. Yeah. Uh-huh. Uh, yeah, absolutely. I will quickly pull up that article that I wrote very quickly. Which one? H2 is similar, but I mean, sometimes some of them will have a better performance. So you can all join in. Yeah, yeah, so that people can hear. Yeah, yeah. I will cover this. I mean, once everybody is done reading through it. Yeah. Done. Bhavna? Shall we begin, people? Okay, so we'll just quickly address Ravi's question. Folks online, can you hear me? Can you confirm?
Yes, sir.
Yeah, okay,
Yes,
great.
sir, we can hear you, sir.
So I think, I mean, you can go through my LinkedIn article, but we're just looking at with respect to the auto glue on or auto ML packages, what is the scope for the data scientist, right? I mean, what are we going to be doing, right? So first of all, the field is still growing, and then it's saying, it's going to have the highest amount of growth compared to any other vertical or any other area till about 2029, based on US Department of US Bureau of Labor Statistics, right? To your point, Ravi, where exactly we will be spending the time? This is where you'll be spending the time. Data cleaning, feature engineering, making sure that you can access the data, all the tables are clean, all of the things. That's where majority of your work will be coming in, right?
Sir,
Yeah,
are
data
you sharing
wrangling.
your screen?
Oh, okay. My bad. Just a second. I'll just share it. Okay. Now is it visible?
Yes, yes, sir.
Yes, sir.
That's
it is.
visible.
Okay. Yeah. Yeah. So the first takeaway was that, I mean, we are still in a growing field till about 2030 or beyond, in my view. But most of the time we'll be going in dealing with the data itself, just preparing your data for the modeling and all of that. A lot of places, what we are finding is that people may be jumping onto the bandwagon of AI, data science, but you don't have leaders who actually understand the data or the leaders who think that way, right? I mean, they will be more intuitive and all of that. So that's where, I mean, your challenges are that you may still have to convince them in terms of what lies ahead and how to use the models. So that's a challenge that you still face, right? So it's not necessary that actually you will have it across different organizations. Soft skills, as we know, I mean, it's very, very important. Constant education is very important. This is important in my view. Segregation of roles. So it won't be just data scientists. I mean, you will see that people will be now get bucketized into machine learning engineer, data engineer, AI specialist, AI translator, and so on and so forth, right? So depending on what you're actually looking at, I mean, you may have a slightly different role and the charter of that role. One of the problems that we still face is the slow model deployment, right? So development to the model deployment, the life cycle could be very long. And that sometimes creates a problem for the model usage because by the time you get to the production, the underlying situation has changed, right? So that's not necessarily a guarantee that your model is going to perform in those situations as well. This is where your auto ML is going to come in, which is the citizen data scientist, right? So people who may not be trained or have a formal education, but they know enough based on their own interest and based on what they have actually understood from their peer group that they can deploy the auto ML model. They can actually understand what is happening and they can build a working model that they can then take to the data scientist and say, by the way, does it work or not work, or what are the areas that we could improve, all of those things. Right? So that's where the auto ML is really coming in. And you will have the augmentation of the tech staff with respect to people who want to take it up, right? So I think, I mean, this could be a role that all of you can sort of like, consider as a bare minimum in your company, right? I mean, even if they don't give you a formal role, you could be the citizen data scientist. That I mean, if they ask you to do something, or if you know there is a certain opportunity, then you can say, "I can do it." Right. So that's what basically we're looking at because every company requires them, right? This is more about the model performance. That any model that you have built is not built for perpetuity, right? So you will have to monitor performance and tweak the performance of the model or build a brand new one because world is changing at a very, very fast pace as we speak, right? Less importance of coding to your point, Ravi. It's not necessarily heavy duty coding that is required now, except for your data cleaning and the feature engineering. Modeling itself will not require that amount of coding. You have seen yourself, I mean, model doesn't require that amount of coding. So it's more about the data handling, right? Data cleaning is more about missing values, outliers, things of that nature, right? So bogus values, um, all of that. Basically, the data that you text is stored as numbers, numbers stored as text. Percent sign is missing. Some of the places percent sign is there. Some of the times they will say PERCT. like all the the thing that we've seen earlier happening. Can you speak in the microphone so others can also? Just for others' benefit, yeah.
Feature engineering, Ravi, is just like deriving a new feature from the existing feature, like what will be better, right? For example, let's say we have length and breadth. Instead of using two features, we can just have the square of the value. So like these things are termed as feature engineering.
Because I'm hearing like this is now the buzzword, like feature engineering is coming more nowadays. And this cloud, the model, like
Hmm. You're muted, I think.
Model can be used for the
quick pilot
pilot
project.
project.
That is what like with less knowledge and you want to quickly build something and showcase to business. So that is the best way, I think.
Yeah, absolutely. Yeah, so I'll just talk about the feature engineering very quickly, so that you are clear about the doubts, right? So what we mean by data cleaning, right? So data cleaning, for example, is, let's say you're looking at the APR, which is the annual percent rate, which is interest rate. It should be, technically speaking, float, right? Annual percent rate, which is the interest rate in the finance term, right? Yeah, right. So APR should be a float, right? But now they may store this as 23.94%, right? And this is stored as a text. So then you have to do the typecasting to convert the text to float, right? They may also, some places, miss out the percent. They may say this, right? I mean, if people are really like, very, very scientific, they may say 23. It may happen. So don't doubt that, right? 23, depending on the company that you're getting the data from, 23.94. Like the JE rank, they will actually split it till the like 7th decimal places, right? So now how would you get this to talk to the same? And so there's going to be like many, many different things where the data is. Then besides that, we have the usual suspects, like you have your missing values, right? Your outliers. What else could be there? Yeah, I mean, in terms of the data, yeah, I mean, you can, so standardization is more about the feature engineering actually. So missing value, outliers, all of those things. I mean, there are many other things, right? I mean, what bogus values, for example, right? I mean, all of those things are something that are all data cleaning parts. So basically getting your data ready. Then, all of that is feature engineering. So that is not data cleaning, that is feature engineering, right? So feature engineering is when you have, let's say, yeah, I'm just going to begin with more basic. So feature engineering is more about, let's say, you have 90 days balance and you have 30 days balance on their account, right? I mean, on their credit card account. So 30 days balance and 90 days balance. Now you create a new variable, which is going to be a ratio of 30 to 90-day balance. And you're saying, is this amount going less than one, more than one, or staying the same? This is feature engineering. Correct. So this is basically creating new features based on what you already know, and you're trying to get a trend about that. What exactly is happening in my underlying data and whether this data makes sense or what is happening. So that's what we call as a feature engineering. All the other things that we've spoken about earlier, like the standardization, dummy coding, all of that is also feature engineering. So I hope this creates the separation in your mind. Yeah. Okay, awesome. So that's what basically will take more time and bandwidth from us. And then the last two things are very, very important. I mean, ethical AI. What do you mean by ethical AI? What could be the unethical over here? Any examples where people are misusing things? Hi, Manju. Grab a seat. Go ahead. Just on the microphone so others can also hear you.
Having transparency on the what we are doing and being clear, having one is transparency on what we are doing, how the data is consumed, and also explain it in terms of the how data is consumed and perceived to whoever is impacted.
That is correct, right? So ethical is basically making sure that you're not doing something which, if publishes on a newspaper, you will feel bad about that, right? So for example, if I say on the front page of the Times of India that Manjunath did this, right? If you shouldn't feel bad about this, right? Ki, boss, why did I do that, right? So that's what basically mean by, huh? So that's what we mean by ethical, right? I mean, you may be legally correct, legally you're correct. Like, I mean, you can use that data, but ethically you're wrong, right? So for example, people may say that I am not separating, this happens typically in the US areas, right? So they will say, I am treating everybody as an equal opportunity. So African American are not at a disadvantage, right? They'll say I'm not doing any segregation. But the moment I start using zip code, for example, in my model, right? So generally speaking, I mean, you'll see a cluster of communities where more African Americans are living. So the moment I plug in the zip code, I'm not using race, I'm not using ethnicity, but I'm using zip code as a proxy for that, right? So I can still do the discrimination. So that's what basically mean by ethical. Any other examples that anyone can think about? Some other way of doing that, yeah. Other examples anyone can think about unethical practices? We can do that in India, right? I mean, so but I'm saying like in other places you cannot. So for example, age cannot go in your credit data, right? So you cannot say I'm not going to give a loan to senior citizens, technically speaking. But in India, we can plug in the age. We are not necessarily at that high bar as of now, right? We can plug in the people ask openly what religion you have, Hindu, what caste you have, Brahmin, this, that. I mean, that is not actually something that you should be using in a form at all, right? I mean, so I just filled my son's form and they asked for everything, like, I mean, all of those. Exactly. So, yeah. So all of those things are still being used in India, but I mean, that is not there some of the developed countries. So those are some of the things that you are looking at, right? The last one is it is going to be an evolving field, right? It continues to evolve and you continue to need to upskill and learn new things to be staying competitive in the market. So I hope that addressed some of your question with respect to the auto glue on and what we're doing, right? Awesome. So now let's move on to, and you have, of course, this HBR article, which I summarized. You can go through that and it's there on my LinkedIn post. I will now switch gears and talk about this, which is the imbalanced data. So what is an imbalanced data? Who would like to start first talking about that? And what is the problem with the imbalanced data? Just unmute. Yeah.
So in case of machine learning, so machine learning models, they used to learn from the data. And when the data is imbalanced, so they will try to learn more things from the category where they have more information, and they will try to means that they will miss all the information which are very less less number of data are there. So it will kind of not learn or not generalize the entire data set from.
Okay, 3 minutes.
Yeah, it's basically uneven distribution of the data and yeah.
What is the problem with that?
What I feel, it's like reducing the effect of majority data. Yeah, can you hear me? Can you hear me?
Yeah, I can hear you, Sir. Yeah, go ahead.
Yeah.
Just too many things on my dashboard to manage simultaneously.
Oh,
Go ahead,
okay.
Sir. Yeah.
It's like reducing the effect of majority data, resampling that way, that minority data, whatever features that we can have in the minority data, we resampling the majority data accordingly.
Right. You're talking about the like the fix that are in my view, but I'm talking about the imbalanced data and what are the issues it causes.
It gives, if data will not be balanced, it means it will give the accuracy considering the majority data. Will not
Correct.
consider much the minority data. So
Right. So the majority basically overshadows the other class, right? So that's one big problem. The other one is the metrics that you're generating be confusing, right? So we talk about, I think this article spoke about the metrics trap. What is a metrics trap? Can anyone give more clarity on what is a metrics trap? Trap or metric trap, metrics trap, what is it? Just unmute yourself, Manjana, if you're there, or you can speak in Pranesh's.
The metrics, whatever is given, we think it is of high accuracy. But even if a blunt model, like if we predict everything as false class, so even we can see 98% accuracy if there is a 2% distribution of the false class. So that will, for us, it is still 98%, but actually nothing underlying is working.
That's exactly. So the metrics trap talks about. So the metrics trap, folks, talks about like when you have, this sort of class imbalance, right? So let's assume that we have healthy people. Let's say we are doing a rare disease detection, right? So healthy people and sick people. Very, very rare disease. I don't know, what disease we have, but let's say very, very rare disease only happens to 0.5% of the population, or even more rarer. Huh? Monkeypox? Monkeypox in India. Okay, so let's say we are looking at monkeypox, right? Monkeypox. And assume this monkeypox has no visual symptoms that you could tell whether this person has it, doesn't have it, and you have to test the people, right? I want to be lazy, and I don't build even a model, and I say 100% of my people are healthy. 100% of my people are healthy. What is the accuracy of my prediction? Without even building any model, because I know this fact that 0.5% people will be typically sick, and 99.5% people will not be sick. And I don't do anything. I don't even lift my finger. I say 100% of my people are healthy. What is the accuracy I have? 99.5%, because you are right 99.5% of the time. But is this a good model or not? So it's 99.5% accurate. So that's why the layman will talk about the accuracy, right? But we don't talk about that. What will we be talking about? What other metrics do we have which are more robust? Right. So we'll be talking about the precision and recall, right? And you'll see those metrics will be drastically affected. So recall for sick people will be 0, precision for the sick people will be 0, right? Because we are classifying everybody as healthy. So we don't have anyone that we're predicting as unhealthy, and we are not detecting any unhealthy person as well, right? So is this a good model? No, because its precision is going to be how much? Let's see. I'm just making it really more interesting. What is going to be precision for healthy? And what is going to be recall for healthy in this model that we built, that we're saying everybody is healthy in this mix? Precision will be 0.5 divided by, precision will be 99. 5. Okay, so precision is when model says I have detected the healthy person. Model says 100% of the time I've detected a healthy person. How many times your model is right? So precision will be 99.5. What will be the recall? So recall will be 100% because all the healthy person are being detected by my model, right? So for the healthy people, precision will be 99.5. Recall will be 100%. But what will be the precision for the unhealthy people? 0, because it's never predicting any unhealthy person, and it's not able to detect any unhealthy person, right? So that's what basically we're looking at. So let's make it slightly more balanced now. So let's say I have class 0 as 90% and class 1 as 10%. Without building the model, I say everybody is class 0. What is the precision for 0, precision for 1, and recall for 0 and recall for 1? Same picture. Same, there's no difference, right? So because I haven't built any model, so, and I'm saying everybody is 0, so that means my accuracy will be 90 out of 100. all the zeros are being detected by my model. So that's going to be 100% recall. Precision will be 90%. And for these guys, it will be 0. So that's the problem that we face, right? And there are many, many real world challenges, right? I mean, let's list out some of those challenges where we face this sort of situation. One is fraud detection. Exactly. Rare disease. Huh? What about terrorists?
So,
Okay, right. So, right. So, like the threat, maybe threat detection, right? So, like, I mean, in terms of, some of those signals that we're looking at. Okay, any other examples where things are very rare? Spam? Spam is like, I mean, most of the mails have spam only. I mean, it's the other way actually. You want to detect the genuine mails. Otherwise, most of them are spam only. Any other rare? Right. Yeah, I mean, I think the threat detection sort of covers that. So you can think about like, it's a cyber, like, your website has 1 million visitors every day. You have one bad person who is visiting your website. So how are you going to detect that one bad person from 1 million people who are visiting your website? So that's more like an anomaly detection. Anything else that you can think about where this may be happening? Rare disease, rare phenomena or anomalies. Okay, like what in text? Number of. Okay. What else? Yeah, taxpayers. I think. I mean, yeah, will be good, right? I mean, but yeah. Hmm? Churn is slightly more balanced. I mean, 1090 still you can actually make out something, right? But I mean, I'm talking about like if your one class is 0.01, the other one is 99.99, then all the models that you're building will struggle actually. So something is very, very rare, right? I mean, that you have to detect. I mean, that's where the class imbalance really comes in terms of making sure that you're.
I don't know. Like airlines, Six Sigma kind of operations.
Zarar is saying airlines Six
operations,
Sigma.
Yeah.
Yeah. So I mean, you can then think about like all this, but I think Six Sigma is a great example that Zarar is bringing in, right? You're looking for that event which might be 1 in million, right? So if you say that I'm really Six Sigma, that means you have one event happening per million, right? So I mean, how would you detect that event to be happening so that you can actually detect, right? So that those are some of the applications, right? So there are many different techniques, and some of these ML models that you build will automatically handle that, but it's always a good idea to do that, right? And we will talk about what are the concepts behind that, right? So this is the data that this particular kernel is using, and this is safe driver prediction competition, right? So I don't know what this data is, but I will actually have a credit card fraud data that you can work on, safe driver prediction competition. So you can see one class is like, way over there. So the zeros are way out there, and then we have one which is underrepresented, right? So these are the people who are unsafe, for example. And what you can do is there are two ways of handling this. Who would like to describe what we are looking at in this picture? What do we do? I mean, so we're talking about the underpinnings of this. So we're talking about what we could do. And let's see if anyone can explain what we're doing over here. Yeah.
So original data, we can see orange is very, very less. Okay, and we are making undersampling, so which is having more data. So we are taking only sample over there and making it balance with both orange and blue. On the other end,
Right.
which is very less, we are just resampling. Okay. And then we are making the class balance.
Right.
We are adding here it is subtracting.
Absolutely true. So thanks for that, Tanmay. So you can see what we are looking at over here is, let's say this is my 1, this is my 0, whatever it is, right? So 1 is the rare disease, 0 is not having that disease. So what we can do is we can say, okay, you know what, if I throw in this data in the model, because this class is overrepresented, this is gonna overshadow the learning of the model because this is just way too much data for the model to learn from, and it will learn that behavior of the 0. So what I could do is we can actually cut down the data and make it exactly the same size. So this is what the concept of the undersampling is. And each of these sampling methodology has a pro and con, right? So what is the pro here? That you are making them equal and you are well balanced, but then you're losing this data, which the learning could have been taken from. Yeah, right? So then you have basically chopped off your data that you're not learning from. This is the other way around. So what it is doing is basically this is saying, okay, you know what? I'm just going to duplicate this data. Just oversample this data. So when I'm actually not necessarily duplicate will come later on, but let's say I'm taking a 20% sample from this population, I'm going to take 100% sample from this population, or do more of that sample to really make them equal in terms of the representation. So these are two strategies that we follow, and we'll look at some of the packages which actually help us do that.
Usually, like this is a classification problem where we want to classify 190 basically. Can we not use just one class classification where we can learn more of it? Anything which is outside of it, we can straight away tell it belongs to other class. Because like there's a pros and cons here. We are losing in some case, in another case, just duplicating. We are not learning anything. We are just bluffing the model. But can it do using clustering? Is that better, or this is?
There are multiple approaches, and depending on how complex your data is and what level of precision and recall that you desire, each of these techniques are a good bet.
String is not able to do that. Even if you do oversampling or undersampling, there is still noise in data. That means still model may not behave properly.
Yeah. And what happens is, I mean, we will not necessarily know whether this is the right way or this is the right way. So whatever fits your data better. So people try different way of sampling, right? I mean, what you're speaking about, that's also true. People will say, no, I'm not going to do any undersampling and oversampling. I'll just train my model like this, right? And I will use models inherent features like the class balance, right? So you would have seen that in logistic regression, we turn on that. So it will actually over-index on learning. So multiple ways of doing that. But like, I mean, in case if you want to do class balancing, these are some of the techniques that you could definitely give a try, right? So random undersampling, random oversampling, we'll use a package called as imbalance to talk about that, right? I'm just talking about what are some of the main ways of doing that. So this method or module, imbalanced learn in Python, will help us achieve some of these things, right? So you can see that from sklearn data sets, we are creating this data, and over here, we are importing random undersampler. And then we can actually say that, you can go ahead and do the random undersampling, and I'll show you when we do the Python, and then it will do it. Similarly, random oversampler is there. Then we have Tomek links. Who would like to explain what is a Tomek link? All of these are available in Python. Yeah, Bhavna, you want to try? Yeah. I'll just mute myself.
So in Tomek links, what it will do is it will take up the nearby, like whichever are of opposite classes, nearby it will create the links, and it will remove the whichever is the majority class samples.
Right. So that way we can reduce the majority one, and proportionally it will increase the undersample one.
So it's basically saying which pairs are similar to each other, right? So like, I mean, between the blue and orange in the, like, the three-dimensional space or the n-dimensional space, which two observations are similar to each other. And then it's going to remove the one which is overly representative to, handle the class imbalance. Why it's removing that? Because everything is the same. but one is a fraudster, the other is a non-fraudster. So is the model going to learn anything incremental? No, because all the other characteristics remain the same. One person is a fraud, the other person is not fraud. So I'm better off removing those data points and look into the data points which are much more separate in terms of the balancing of the data. So that's the general concept about that, right? So now you can see it's cleaned up the space and you will have more dissimilar data that you're looking at. So you can again import the atomic links and do this. Then we are looking at cluster centroids as well. So that's another method where you actually look into the clusters and based on similarity, you will remove certain data points. And the last one is the very popular one, which is what people use a lot of times, which is SMOT, synthetic minority oversampling technique, right? So it will create a synthetic sample. Like, I mean, it says, okay, there should be something over here. I'm finding something missing over here. So it's just going to create that synthetic data for you. Over here. So it basically fills the space wherever it finds that there's something missing, which ought to be there. And that's what the technique of the SMOT is really, right? So that's also something that you can try out. So now let's go ahead and look into this package very quickly. And if you go and say imbalance Python, you will get to this one, imbalancelearn.org. And actually, let me go back. Imbalance learn, I think that's what it is. Yeah, so I think that's what it is, but I'm looking for some examples as well, which you can actually start practicing. And there are many other techniques, so I'm not actually covering all of them. So each one of these is going to have certain nuance that you can actually look into. Okay, let me just go back and see what exactly this guy is using. So imbalance combine, and we are using, because there are many packages there as well. Imbalance learn is what we're using over here. IMB. Yeah, IMB learn is basically what we're using as a package. IMB. This is the one that we are actually using, right? IMB learn. So they have deprecated that. That's why I'm not finding it. So now they're saying imbalance learn is what we're actually looking at. And there are certain dependencies that you must have. So you can go ahead and try to install this package, folks, very quickly. Pip install imbalance learn, and we can then try out different things over here. And in the meantime, what I can do is I can also give you the data that you can play with very quickly. I think that is going to be a good data that you can experiment with. Sorry, what is the problem? AC. It's cold. Yeah. Acha, sorry, my bad. Yeah, it's for the projector. You can do pip install imbalance learn, right? I'll just keep it there in the chat window as well for you for quick reference. Yeah, so this is get your package installed. And then let me find out whether we can download this data very quickly. Kaggle credit card fraud detection. Yeah, this is the data. So if you can log in with respect to your accounts and download this data. And I'll just briefly speak about what this data is, right, very quickly. And you can give it a try very quickly. Yeah, so this is the data I was looking for. So let me know once you have installed this and you're good to go. It is different. No, this data is different, but I'm saying just install that package. Once you've installed that package, then we can go forward. Is it? I'm not talking as of now. Just a second. Yeah, folks, can you hear me now? Is it better? Online people?
It's better.
It's better now because since that, I'm having a difficulty to hear your voice.
No, I was not talking actually. So you may be hearing some background noise actually.
So shall we copy these codes now?
Yeah. So you can actually not that code. So I'm saying just install the package and then download this data, which is credit card fraud detection. I'm just trying to log in myself, but it's not remembering me for some reason. Let's see if it works.
Sir, I have downloaded it, sir.
Okay, then you can share with everyone.
Yeah.
Yeah, you might be already registered. So okay, there you are. So I'm also able to get in now, right? So I just so what this data has basically, this is a real data from I think one of the European countries, right? And they are actually looking at what are the transactions which are fraudulent, right? And these are the variables V1, V2, V3, V4, and so on and so forth, right? What do you think these variables are after you take a look at this data and all of that? And then let me know if you have done that reading very quickly. So this is a data which is very correct. Yes. And I think Saikiran has already downloaded and might be sharing that, but it's a big file, so that's something probably all of you have to download yourself.
Yeah, sir, it's very big file, sir. I'm not able to
Yeah,
find it.
correct. Yeah, so everybody must
I'll be
download
uploading
that.
on LMS, sir.
Okay, sounds good. Correct. Yeah, it's a big data actually. So once you've downloaded, once you so this is very frequently used for anomaly detection, right? Because we are looking at the fraud and what exactly is happening over here. Yeah, no problem. Take your time. All right. So once you have downloaded data, just do a quick profiling of the data in Pandas profiling and let me know what are some of the insights that you can draw. Now, in interest of time, what I'm going to do is I'll share this um, Google Colab or IPYNB file that you can try to leverage. But I would like you to try like different techniques that we have spoken about to see what gives you the best result, right? So this is something that I just grabbed from one of the articles. Right, so let me just share this as a download. because we do have a deep learning topic that we want to cover today, so we don't want to spend too much time talking about this. But I'll, in interest of time, share this file with you. Or maybe Saikiran, I'll just share with you. Or maybe this is the right link. I think this is the right link. Yeah, that's fine. Right. So I'm sharing this Jupyter notebook with you. You can leverage that, but try out like different techniques for balancing as you've discussed earlier on and see what gives you the best result. And then we can quickly do a walkthrough, whoever would like to talk about that. I believe you have the file, folks. Can you confirm?
Yes, sir.
Okay, awesome. Hmm? Everybody has a file, folks? Yeah. Then you can begin with this example that I was talking about. Just import the file. and execute this Jupyter notebook. You may want to take out certain codes or certain sections that you're not interested in, but let's see what you're able to accomplish. And try different techniques of the class imbalance. You can definitely do a quick Google on how to balance it. So this is how the data looks like, right? So what are these V1, V2, V3, all these values? Can anyone tell me? What are these V1, V2, V3? Can you unmute yourself also? Yeah. Go ahead.
Yeah. Maybe these are the initial features that we have in the data set.
Mm-hmm. But why are they like this? Right. Yeah. So just look up the article or the link in the Kaggle. Traditionally, you'll find that these are nothing but the principal components. You spoke about the principal components earlier on, right? Where we can replace the original data with components. So this is a component one, component two, so on and so forth. You don't even know what the underlying values are, but the components are representing the data for you, right? So, and another way of, if you want to share some confidential information from your company to somebody else, just do the PCA. They won't even know what that data is, right? So you just have the PCA, and PCA will actually have the underlying data characteristics, have the same number of components, and everything is so messed up that they cannot make out what exactly it is, right? So these are all random values. It may seem like you cannot really interpret what these values are, right? You cannot make out whether this is a salary or this is the age, anything of that nature. So PCA does a remarkable job in terms of anonymizing your data as well to really make it suitable for anything that you want to do, right? So they have done that because it's a confidential data, right? The only thing that they haven't done the sort of like a PCA on is the last two variables over here. What are these variables? The transaction amount on which a credit card fraud may have happened or not have happened, and then whether this is a fraudulent transaction or not. Right? So this class 0 means non-fraud, class 1 means fraud. And what was the amount there, right? So our job is to build a model to detect the fraudulent cases and get the highest recall for the fraud. And after you do some of this math, you will get to understand the fraudulent transactions are only 0.173%, which is a fairly good representative of any credit card portfolio. So if you were to build a model to have the highest recall for the fraud model, how would you do that? That's the challenge that we're trying to solve for, right? I hope this makes sense, everyone. File upload itself may take some time in Google Colab. Yeah, it's a big file. How many observations do we have? Can anyone tell? If you open the file in Excel, we have 284,000 transactions, out of which only 0.2% of the transactions are fraudulent. So it's literally finding needle in the haystack. And that's what the challenge is. Hmm. Yeah. Anyone has been able to upload the file? Is it? Acha. So you can try in local also if you want to. Yeah, why not? Jupyter will be boom boom very fast. No, local will be very fast. I think it's just the collab. They don't let you upload beyond a certain speed. So just do it in the local. That may not be a bad idea. Yeah. Parallel processing. I don't think I do. Like, I mean, what are you trying to do? Just like, I mean. Hmm. Acha. Let me dig up something. If I find something, I can definitely share with you. Yeah. You don't have to follow everything that they're doing. Just do some basic statistics, but try balancing your data and fit a logistic regression as it is. And then after building or after doing the balancing using different techniques and fit a logistic regression. That's all we want to do. But good information for you to do in terms of, if you want to execute other pieces as well. Acha. Got it. Your main objective is to fit a model using logistic regression as it is, and then do the class balancing and then fit it. Class balancing using SMOT or some other technique, right? And then see whether you find any difference. Oh, you can take a break, folks, if you want to go for a quick break and then come back and keep talking. You want to continue, you can. Right. You can take a quick break. While you can get the file uploaded. Right. That's what they actually put like anywhere. I mean, we do lab, like not all of lab, but they have